All right. Good morning, everyone. I see people are joining in. Thank you very much for coming see us today, this third day of our webinar series. My name is Renata Barros. I work at the Geological Survey of Belgium, and I am the coordinator of the GeoConnect³ project that is organizing the events this week for you. So I will be your host today while we discuss the very interesting topic of framing geothermal energy, geothermal resource management, sorry. So we have a break tomorrow and one last webinar coming up on Friday at 9:30 a.m. Brussels time. So we have been discussing different topics these past days, and Friday we want to bring them all together under the perspective of subsurface management. So I really encourage you to come back on Friday, and you can still register on the event page. The link should be there for you in the chat. So this is our agenda of today. We have two great talks to look forward to, and then we will have a Q&A with our two speakers and a final interactive session. But first of all, I want to introduce the nice group that we have today. I will just stop sharing for now. So I will start with our guest speaker. Today is Estelle Petitclerc. She's a geothermal energy expert and our colleague here at the Geological Survey of Belgium. Hello, Estelle.
Hello, everyone. Thanks, Renata, for the introduction.
You're welcome. And then we have our project speaker, once again, Chris Piesens. He is a researcher at the Geological Survey of Belgium. Hey, Chris.
Good morning.
And our moderator, André Bocin-Dumitriu from the Geological Survey of the Netherlands. Hey, André.
Hey, good morning, everyone.
So thank you very much for joining us today, especially our guest speaker, Estelle. So before explaining how this will work and starting with the presentations, I want to give a quick background on the GeoConnect³ project. And if you watched this any of the previous days, I will apologize because this will be a bit of a repetition, but you know that it will be brief. So just a second while I share the screen again. Okay, so you should be seeing my screen now. So our project is part of the GeoEra research program funded through Horizon 2020 Research and Innovation Grant. And I guess that everyone watching today knows that our society is strongly dependent on resources coming from the ground below our feet, or the subsurface. Has the main objective of contributing to the optimal use and management of the subsurface in Europe. These uses of the subsurface are covered by three research themes: geoenergy, groundwater, and raw materials. And a fourth theme is the information platform, which is our common objective because we want to make all the data freely available online for visualization and download. So GeoConnect³ is part of the geoenergy theme, along with other projects that cover different aspects of geoenergy resource. For example, inventory of European faults, cross-border 3D modeling of the subsurface, and very relevant for today, project on geothermal energy as well. But GeoConnect³, as the name suggests, is a point of connection between all of these projects and also others in the groundwater and raw materials themes. And we want to provide a robust model that can accommodate types of geological information that is being generated. But before I go into that in more detail, I want to talk a bit about our motivation behind it. So the idea of our project came after realizing that resources coming from the subsurface will be needed more and more, because we're going through big changes over the next decades to achieve climate neutrality goals in Europe. Increasing sustainability, access to clean water, climate action, a lot of these sustainable development goals for a better future, they rely on different uses of the subsurface. And sourcing affordable and clean energy is something that we see as especially related to new and extended uses of the subsurface, such as geothermal energy or energy storage. And the subsurface is ruled, of course, by geology. So geological information will become more and more crucial for good decision making. However, science and policy is not as close together as we would like. On one side, there's a lot of geological information out there, and our knowledge of the subsurface is constantly improving. But is this information accessible and understandable? And on the other side, guidelines and decisions about the uses of the subsurface are already being made, and decisions will only get tougher in the future. So is the scientific information out there being used to its full potential? We think the answer to both these questions is no, and we want to help close that gap. And to do so, we gathered 20 partners from 16 different countries, and we have two cross-border case areas, the Ruhr-Rhine and Pannonian Basin, and 2 one-country pilots in Ireland and Germany. And just a quick note that this webinar series has some focus on the Ruhr-Rhine area, but that a similar event is being organized later this year for the Pannonian Basin area. But anyway, we all share a single goal: to develop and test our new methodology to prepare geological information related to the subsurface in a more understandable way. And we want to make them easily available for stakeholders on GeoEra's online platform. And we hope this will help bridge the gap between science and policy, especially in subsurface management. So what is this methodology that I keep talking about? We are rethinking the way to present geological information. And we're doing this by using information available in conventional geological maps, 3D models, etc., but digesting this information to make it more intuitive. And we do this by looking at the geological features in terms of their boundaries or their limits. And we're also incorporating information that is usually overlooked, but that point to specific geologic manifestations. So the combination of these two types of information gives us our structural framework model with annotated geomanifestation data. And like this, our aim is to improve geological understanding of any area. So, sorry about that. So just quickly, the timeline of our project. So we started in June 2018 and will end June next year. The first version of our methodology got ready 1 year after the project started, and now it's time to test it. And part of the testing is to get the feedback from potential end users, so you that are watching us today. And this is what motivated us to organize these online events. And as I mentioned, a similar event will be organized by the Pannonian Basin area later this year. And we will have a final joint event for stakeholders early next year. So what can you expect today. So we will start with the presentation from our guest speaker, Estelle, on the topic of geothermal energy. And we'll follow with the GeoConnect³ presentation by Chris to demonstrate how we can incorporate this in our project. We will then have a Q&A session with our speakers, and then we will end with an interactive session using polls to get the feedback from you about what you've seen. During the two presentations, please write your questions using the Q&A button at the bottom of your screen. And you can upvote existing questions with the little thumbs up, so we know if many people have the same question. And to get you prepared for our interactive session later, I will do a test now. So we're using Poll Everywhere. It's very simple to participate. You go to pollf.com/ggera900. The link should be there in the chat for you. You register with your name, and then you get ready to answer our test questions. So while you get set up, I will go ahead and open the first question. So if you participated in the previous days, you can just go ahead and answer again because we get this information per session. So the test questions will be the same. Apologies for that, but it's interesting for us to know for sure. So first question is, what is your background? And if you have a background in geoscience, please specify the area like geochemistry, hydrogeology, or something like that. So we start with some results there. We have geophysics, hydrogeology, geoenergy, EU policy, geophysics, geoengineering. Okay, that's nice. Seismic interpretation. Okay, that's very nice. Public policy, environmental economics. Very interesting. So I wait a bit more for a few more results to come in. All right, that's very nice. Thank you for participating. So I'm gonna move on to the second test question. Where are you based? Please click on the map. And if you're not based in Europe, you can use the little map on the top right. So let's see how it spreads today. That's nice. There are a lot of people from our Route to Rhine area, which is nice. Okay, very good. So the test worked well. That's great. I think you're all set to participate in the polls later on. Very good. So without further ado, I think we can start with our presentations. So we will start with Estelle Petitclerc, and she will be telling us how deep is geothermal energy in Wallonia, Belgium. So Estelle, whenever you're ready, you can share your presentation with us.
Yes. Connecting the presentation. So can you see my screen? I'm sharing it. So Renata, can you see my screen? Yeah.
It is there. It is there.
It is there. Perfect. So first, good morning, everyone. So first of all, yes, thanks a lot for the invitation to participate to this webinar, to this GeoConnect³d webinar. And I'm really pleased to talk about deep geothermal energy today. This presentation will focus on the southern part of Belgium, to Wallonia. So first of all, I will introduce briefly some geological survey activities in the past, and also the main parameters that are needed and necessary for geothermal energy. Then we will have a look on the deep geological information we have and what could be the Walloon area of geothermal interest. We will check if the resource is already proven in Wallonia. And at the end, I will present you some ongoing results of ongoing progress that we are doing in two projects mainly to improve the deep geothermal energy implementation in Wallonia. And then I will conclude briefly. So first of all, the Geological Survey is implicating geothermics for a very long time. It starts in 1952 with a turnout geothermal well drilling in the Camping Basin, where a temperature about 100 degrees was found at 2.1 kilometers. So it's on the northeast of the country. Then several geothermal wells were drilled in the 70s and 80s, 3 in the Mons Basin, Saint-Guilain, Douvrin, and Glin, and 2 were also drilled in the Camping Basin. You can see the Mersbergplaat on the right, the drilling rig here on the picture. And we had also two drillings in the eastern part of Wallonia with Chaudfontaine and the Sinsgraven borehole. Then, since 2009, the Geological Survey is mainly involved in research development in shallow and deep geothermal energy through different research projects at regional, national, and European level. And they focus mainly on geothermal exploration with a lot of testing, drilling again, and also about focusing on geothermal resource assessment and mapping. And last but not the least, we are also performing some geoeconomic modeling. So on the bottom, you can see some logos of the different projects where we were involved. And on the left side, you have all the projects that we are currently involved. I will talk a bit briefly about the Interreg Northwest Europe project called DG Rollout, and also the MEAD project, it's a ASH 2020 project. So there is ingredients for geothermal energy. So there are 3 apparently simples to address a potential for deep geothermal energy. First of course, we need heat, which is naturally stored everywhere in the subsurface. But we have it depends of the local geothermal gradient. And we will see in Wallonia that the geothermal gradient is very diverse in function of the regions. Then we need a fluid which acts as a carrier to extract heat from the reservoir toward the surface. And the geothermal fluid can be in the liquid phase, in the steam phase, or a mixture of the two, depending on the temperature, of course, and the depth. And the last parameter needed is the permeability of the reservoir, which is the main complicated to address from the surface. This is a property that allows the fluid to flow across the reservoir and eventually to be produced. So now if we look at the geological information we have in Wallonia, we can first ask us what can be the deep burial bird potential aquifers that could be a target for deep geothermal energy, meaning that what kind of layers, what kind of rock could be enough permeable to host a deep geothermal reservoir. So when we look at the stratigraphic chart of Belgium, we have 4 layers for geological horizons that we consider that could be potential aquifers. We have first a sandstone conglomerate from the Permian and Upper Trias. Then we have the very important Upper Tournaisian and Visean limestones, which are called the Conlusions, so they are from Carboniferous age. Then older, we have the Ephelian, Jevesian, and Franian limestones. And finally, it's less permeable. We have some lower Devonian that are very interested, certainly for enhanced geothermal system. So the first in blue, the dimension is the focus of the Interreg Northwest Europe project. It's the main target we have in this project. And the second one, the less permeable lower Devonian, is a target for the MEAD project. I will explain that a bit later. So then when we look at the real data we can have from From the subsurface, of course, boreholes are a very nice, interesting source of data. So this is the geological map of Wallonia here, and you can see the location of several boreholes. This is only boreholes greater than 250 meters. We have only 6 boreholes that are deeper than 2.5 kilometers. There is a Saint-Guilain in the Mons Basin, the Faucon, the Walloon and Soumagne borehole in the eastern part, the Grand Haleux, and then the deepest one of Wallonia, it's the Avalanche borehole that reached a depth of 5.6 kilometers. From this borehole, we have only 22 temperature data, which is not a lot. But if we focus on the Mons Basin, Mons Charleroi, the western part, you can see on the right, on the table on the right, the geothermal gradient of this borehole where we have temperature data, and I would say, 60% of them reach a geothermal gradient about 30 degrees per kilometer. Then when we look on the eastern part of Belgium, it's another story. Here it's the table in green, and we have very diverse geothermal gradient here, coming from very low temperature to 30 degrees. So what could explain this very high geothermal gradient variability? So we think that, of course, there is a strong influence of the groundwater circulation in that area, as this area is especially complex in terms of geology and in terms of structures. When you look on the temperature on the diagram here, plotting the temperature against the depth, you have the different boreholes, and you can see that the deepest borehole of Walloon and Soumagne are very cold. On the dashed line here, you have in red a geothermal gradient of 40 degrees, 30 degrees, and 20 degrees here. So these 2 boreholes are even below the 20 degrees. And we observe some drops here in some layers that could be explained by different reasons. And we have the Chaudfontaine area on the top here. That is a very hot anomaly, and this was explained by Grolisch, in the past, some incomes of water across the faults that are make the deep reservoir, the hot water from the deep reservoir allowed to come to the surface. So the temperature variability could be explained by lithology changes, meteorological water infiltration, or by deep hydrothermal circulations through fault or karstic areas. So now, if we would like to understand a bit and visualize the deep underground structure in Wallonia, of course, it's indirect geophysical method like the seismic reflection. You have example here on the decop section on the right. This is some imagery that you can obtain to have a better idea of the main structures and to allow us to know where the deep geological horizons are located and how they are organized. So when you look on all the seismic campaigns that have been performed in the past in the Wallonia, you can see they came from the 70s and 80s again. And you can see on the west part in the Mons Basin that there is a lot of data. And the last 2 campaigns were performed in 2012 and 2019 in the Mons Basin. So we have a very relevant information here. But then we have a little information on the right with the decop section and a bit from the west area. So if I put the geological map, you can see that even the Liège area here is not covered. And we have this central famine seismic section here. So meaning when you look at this map, we have a lot of gaps. And we have no idea about the structures in the central part from all the valley from Namur to Liège, and in the central part south of the synclinorium of Dinan, for example. So if we look at a simplified geological map of Wallonia and the major structural units, Here you can see the outcrop of Carboniferous and also to middle and upper Devonian in yellow, and also the lower Devonian. But the main structure which characterizes the deep geological underground in Wallonia is the complex of the midi fault, which is a fault and thrust belt. And this area is especially complex. So if we take, if you see the right line here, if we try to look at a cross section here along the less or more the Meuse Valley, you can see on the right a different interpretation from the theoretical model. So we have no data, no real data except from the surface here. You can see that there is a numerous divergent interpretation to explain the data in function of the authors. Mainly here, what is different, it's below the midi fault. The midi fault can have different deepening, can have different structure in the Variscan front or in the Allochtone, the Ardennes Allochtone. And what we are looking for deep geothermal energy, it's that if we focus on the dimension, for example, here the dimension could be a layer, a continuous layer below the fault, or could be in function of the author some sheets below the fault, or even several sheets repeating at different depths in function of the state of deformation that you consider in this area. So what we did in the past, we tried to map this area where we can have interesting geological units with a sufficient depth and a sufficient thickness that could be investigated for deep geothermal energy. So this map were built in 2011, and that gives you an idea on what kind of reservoir we suppose in different depths. So this map is for 300 meters to 3 kilometers. And that gives you the different area with the different targets where we think that the deep geothermal energy can be applied. So we classify them, and for example, we decided and we consider that the Mons area and the Liège area are the region where exploration should be a priority. But we also consider that the Devonian and dimension layer below the midi fault are also very interesting region. This is the same map and the same methodology for greater depths to going to 3 kilometers to 6 kilometers. And you can see that what we are thinking is, in the Variscan front and below the midi fault, we can certainly find this Devonian and dimension carbonates that could be very interesting for deep geothermal energy. And in that map, we also decided to locate it all the lower Devonian sandstone and quartzite suitable for maybe for enhanced geothermal systems. And there is, a lot of areas also possible for that kind of layers. So now if we ask us if the resource is proven already in Wallonia, yes, it is. It is in the Mons Basin, where we have 3 deep artesian geothermal wells. They are located here. So you have the city of Mons, and they are represented by the 3 red stars here. So the Saint-Guilain geothermal district heating is about 50 megawatt thermal megawatts, and it's running from 1986. And it delivers it to our 1 hospital, 1 swimming pool, 3 schools, and more than 315 housing. Then after this drilling, 2 other drilling were performed by the Geological Survey, the Glin and Douvrin wells that proves the extension of the reservoir towards 5 kilometers in wide and 20 kilometers long. The Glin well was never exploited since 2 years ago. But the Douvrin well covers the needs of the Bordeaux Hospital, about 7 megawatt thermal megawatt. So depth of the reservoir here in Saint-Guilain is about 2.4 kilometers, where you can see the Saint-Guilain here. The dimension layer here in blue is especially with a very high thickness. And the Douvrin well, the reservoir is about 1.4 kilometer. And in 2018, the geothermia, it's the first Belgian commercial area, about 40 hectares, was launched and is supplying by geothermal heat by the Glin well. So the Glin well was refurbished. And it's nice to see that new developments are going on in that region. And even more, some new drillings are also scheduled in 2021 for EDFI. That will be managed by IDEA, and it's thanks to European ERDF fundings. So now I will go through the projects that are going on and what we are doing to investigate and to improve deep geothermal energy. So the first one is the Interreg Northwest Europe project, DG Rollout. So I invite you to visit the website. The link is provided here on the presentation, so I think it will be available afterwards. And the main aim of the project, it's not only to explore and test the most promising geothermal reservoir, it's much more, but for the Walloon region, it's a main goal. So what we do here is to modelize the top and the thickness of the dimension limestone. And we are also performing some deep underground investigation with geophysical surveys. And then we have the MEET project, which is an ASH 2020 project, which aims at boosting the development of enhanced geothermal system across Europe in various geological contexts and by different means. So we are looking at the avalanche borehole, where the Devonian sandstone and quartzite are present at great depths. And we are also reprocessing some previous seismic data from the Famen area. So what about the geodynamic of the Liège Basin? So we try to modelize here the top and thickness of the dimension limestone. It's done by the acting director of the Geological Survey, Yves van Brabant. So he based all the model on old coal mine maps and veins, and we extrapolate from the latest layer of the coal mine, from the different veins. We extrapolate the dimension and Devonian top here. So we were able to have the first version of the top of dimension limestone here in the Liège area, which is a very complex area with a lot of faults. And what you can see is that in the central part of the basin, the top of the dimension limestone are below 2 kilometers in the central part. And on the left, you have the different fault modelized, but it's still on progress, and a new version will be provided in the next weeks. So next, you saw on the previous map of the different seismic campaigns, we have a lot of gaps. So the idea in this DG rollout is to shed 2 more lines, 2 seismic reflection lines, to recognize the dimension reservoir below the midi fault. So as I showed you previously on the cross section, we have a lot of uncertainty about the deep structure here in this area. So the idea is to answer that question. The target in terms of depth is 6 to 7 kilometers, and we will have 1 line coming from the avalanche borehole to Andenne, Les Saumons, and then we will have a second line on the western part of Charleroi. So this is just an idea to give you where the line in orange will be certainly shot from the previous seismic campaign here with the avalanche borehole and towards the north. So now in the MEET project, we are going to modelize the potential for the enhanced geothermal system in the avalanche area. So first, all the logging data were digitalized, and the different seismic profile from the previous Famen surveys were reinterpreted. And so the final data will be a 3D model of the lower Devonian reservoir. So you can see the different digitalization of the data through the well. And here is the first version of the 3D model of the avalanche borehole with a different seismic cross-section in 3D. So now time to conclude. there is for us, it's clear there is a large potential for deep geothermal energy in Wallonia at different depths for a large scope of use for deep geothermal energy, from low to medium enthalpy. The promising zone of interest as the Dimension Reservoir in the Variscan front and below the Midi-Fault are present in the region where with the highest population density is present and where the high demand of heat and electricity is the greatest. This is the Sambre-Meuse Valley. So yeah, we can say that we are less more lucky because when you match the high demand from the surface in terms of needs of heat and the resources are certainly there, that deserve to be investigated quite more deeply. So the mont spacing should be extensively exploited since the resource is already well recognized. So we consider that this area should be exploited more extensively. Then, of course, as I said before, further investigation will be conducted in the next years in the future, but they will still need to go further, especially in the central part of Wallonia, to fully discover the promising horizons and characterize them in terms of depth, thickness, temperature, and also permeability. So thanks a lot for your attention. So I'm very happy if you have questions, I would be really happy to answer.
Thank you very much, Estelle. I'm thinking in the name of Renata. She seems to have some technical problems. We do have some questions, but we're gonna ask them after the presentation of Chris. Yes. Okay, so Chris, can you take over and then entertain us with your presentation today?
Yes, I will, and I will try. Hello, everyone. Today we're discussing geothermal, and it's a very challenging topic. It's had to do with, especially when you look at deeper levels, it's something that lies quite a bit beyond the imagination of many people that we have to talk to as geologists, or that are listening to us, maybe quite a few maybe in the audience. So that's a little bit of, well, it's the title of the presentation. The presentation itself will also go about how we can work with information in the project, or in the GeoConnect³ project itself. And I just want to shed a little bit different light again on the ambition of the project itself. What GeoConnect³ wants to do, it's not specifically a topic, not even team specific or topic specific project. I mean, we have this now the third session in a row, and we've done geotourism, we've done groundwater, now we're doing geothermal. So it is a very different project than the ones that Estelle has been talking about, which are really ad hoc projects for geothermal energy. What we try to do is something that we think needs to be done, especially if you want to go to broader discussions and to wider discussions, and that is find a way to absorb data and results from different projects and put them in a frame, in a context that allows them to be compared and added on together to make to find a way to relate them to each other. And that should not be simply within one theme, because Estelle has shown I'm not sure, I wasn't counting, but maybe results from 5, 6 or more different projects all put together in one presentation very nicely, but find a more generic way of doing that we can rely on. That being said, it's also about how displaying information is one thing. It's also about how you serve that information to the public. And I will show you things that we have tried in the past 2 years that worked or seem to work at present, and also things that where you're not there yet. So do not consider this next of this presentation to be again. We will talk about geothermal energy, but also about how we can present information or make that information public, and what are the good and the better ways to do there, and where we feel we are still falling short at this moment within this project. And as I said, it's a very ambitious project in that aspect, since it is basically also an open-ended one, and it starts also very much from scratch. There are no other projects that actually are doing this. Now, I will show you that at pan-European scale, and that may be a bit surprising to you, but that there we actually can make quite a bit of sense out of just looking at results from other projects and then putting them into ours or connect them to our the work that we've done in the past 2 years. While if you zoom into the more local scale, actually this becomes much more tricky. And well, I gave here the example of a stake. As a geologist, you probably are not even interested in the stake. You want to go back to really the original product, to the animal. While if you would serve the customer of a restaurant this cow, things will probably go horribly wrong after he tries to bite it and the cows get angry, etc. It will not be a very nice experience. So we have to find a balance there in actually displaying, serving the people the right kind of information. Now, when just to give some focus to the actual storyline of the presentation, these are the two types of rocks that we can think about for serving fluids or for producing fluids for geothermal needs. On the left side, you've got the more traditional way of a sandstone where you've got pore volume quite widely spread, quite homogeneously spread throughout rock. On the other side, you've got a carbon rock with some karstification features in there. I didn't put the scale in here, but since this is a geological survey, I can just show you the samples that lie around in our offices. And these cavities are quite large, even in these drill cores. Obviously, fluids will migrate very differently between these. There's also a third type, which doesn't have any porosity by itself, but where you would need to rely on fractures to actually help you get your fluid moving. Now, but let's focus on the carbonates very shortly, just to link back to one of the previous presentations, the one on Monday, where we were looking also at carbonate rocks and even water flowing through carbonate rocks, but for surface or just as a part of the landscape, so very close to the surface. And actually, in this kind of karstified landscape, wherever these rocks occur to the surface, you can actually have rivers that literally go underground and resurface at the other end of a hill. If you take that kind of rock and put it in the subsurface, even at large depths, it can actually retain that porosity much better often than sandstones can. So that in that way, it's a very interesting rock. And we're certainly also giving it attention. But there is the biggest challenge is actually to find that rock, that limestone that has been modified in such a way that it has this additional porosity. And just to put that into perspective, I'm showing you some economic simulation from another project that we did and which are published. Where we looked at uncertainty for projects related to temperature and to flow rate. And well, we always, Estelle really nicely linked her recipe for an ideal rock here, but I want to go one step further here. For those sites that we modeled, when we looked at the uncertainty, actually the temperature didn't matter that much. That was, even if there was quite an uncertainty range on that, you see that the green, which are the profitable projects, and the red, which are the non-profitable projects, there is a large overlap between the two, meaning that temperature doesn't really determine whether a project will be profitable or not. On the other hand, on the other side, you see flow rate, and flow rate clearly does depend, does determine whether you will have a green, a profitable project or not. And unfortunately, it is how much fluid you can actually circulate through your rocks is both the crucial but also the most difficult parameter to predict. While temperature, well, it's obviously that related. So if your geological model or your seismics or whatever is good enough, you will be able to make a fair assumption on that, especially if you know what your geothermal gradient is, obviously. This is, well, this is one of the reasons why if you move in closer, things become certainly much more challenging. But let's start at the European level first. Here we've got, like in the previous sessions, we've got the map of Europe, but now we're going to start by putting some other results on them before we're actually going to plot them ourselves. And we chose here, well, for specific reasons, but actually quite randomly, the results of the GeoConnect project, which give you a simulation of a temperature at depths of 1 kilometer or surface up to 5 kilometers depth, even deeper, but I'm not showing only to 5 kilometers here. And these data, well, you can still find them and they're out on ResearchGate, but the best way to get to the data is to contact Hans Veldkamp from TNO, who will kindly point you to this kind of offset. Now, we are going to look at the temperature data at a depth of 2 kilometers. And let's start just at the European scale. And there are two zones that maybe pop up. First of all, we've got a very warm island, which is called Iceland, at least a depth of 2 kilometers. And we've got a pretty cold part of the northern Europe, where temperatures seem to be much lower. Let's see if we can do something with that or explain that just with the data that we're going to put on them. And obviously, these are the active plate tectonic margins which we need. We also need to have a look at the previous, well, let's say the different plates that formed Europe together over the past 600 million years, which are these suture lines in blue. We need to take into account the boundary between, here in green, oceanic and continental crust. And we need some, not all of them, but some of these large fault really large fault structures. And if you use these, you get this nice mosaic of Europe. And that's a little bit like Renata probably explained already. We try to look at limits and boundaries first and then define the units based on that. That seems to be a principle that works very well, and we emphasize it in our project. At this stage, we already know why Iceland is so warm, because it's very distinct from any other part in Europe, not because it's middle of the Atlantic Ocean, but because it is based on continental crust and obviously close to the magmatic activity around that Meso-oceanic ridge. And it is also for other reasons. I mean, oceanic crust normally is way below the sea level. Here it is actually forming an island, so it's a very anomalous spot. But most importantly, it's based on an oceanic setting and not continental crust like the rest of Europe. If you look to the cold north in Europe, that is the plate of Baltica. And if we visualize a little bit more, you will see that the hatched areas actually represent the different origins up to 600 million years ago, more or less. And you see that the largest part of Europe has been accumulated quite recently. These are actually all recent plates that have been docked together. And there's a lot of remnant activity related to that, while Baltica has been a very stable platform during all of that time. And that represents, while stability in this case represents lower heat flux. And these are the reasons why these zones are a little bit, can be distinguished already at this scale. So just putting them together and removing the background so you can see the original colors. This is, and only the lines, which are very confusing. At this scale, we actually can say something about these big elements, which is nice for us because, as I said, we didn't really pick this project GeoConnect as providing us data. We just put it, combine it with our model that we made for Europe and see how well this fits. And we can actually tell some nice stories about it. We can even zoom in a little bit more. And now you have here, you see here, well, since you're listening to, I guess you know where Belgium is, the Netherlands. Here, this purple line here represents or is the outline of the Pannonian Basin. Pannonian Basin is quite a big one. It's well, let's say it's Hungary and adjacent zones. That's more or less the Pannonian Basin, and you see it's also quite characterized by quite high temperatures. And there are good reasons for that as well. First of all, the Pannonian Basin here, the outline that we show here for the Pannonian Basin is actually the unconformity of that basin, of which the extent or the outcrop level is your is that purple line. And if you start filling that up or coloring it a little bit, you see that within the Pannonian Basin, although it's a basin sitting there, it's developed not just inside one unit, it's developed inside different units. And in order to go further, you actually need to look at the actual models of there, which are really very big, in which you can see that you look just at the scale. This is 600 kilometers deep, which is quite a bit. You've got here a stretched lithosphere, thin lithosphere, which indeed results in this high flux. But there's more to that, and I'm not going to say too much about it. But you can see also even the different units underlying the Pannonian Basin, the Alcapa and the Tissa one. You can see them more or less coming back here in this temperature map as well. There we have quite a lot of partners from the Pannonian Basin, actually all of them. We cover the whole Pannonian Basin. And I know how complex that area is, and I really do not want to go into more than just these very general discussions on that. But if you want to learn more on that, the Pannonian Basin sessions of the project will certainly interest you as well. I just want to show you here that actually also zooming in a little bit more, you can still make sense of these different spots if you link them to the right outlines that we have here. Another one is the Upper Rhine Valley or Upper Rhine Graben, which you have here. You see it's also a hot one. Not all grabens are high, it really depends on their setting or are hot, but this one clearly is. And well, so it is something that in this case corresponds to one of the grabens, but that's not necessarily the case for all grabens. It depends on their actual history. Let's zoom a little bit more, and as I told you, and well, it's going to get a little bit more complex to actually make these links between observations and modeled results and what we see here. So we're looking here at Belgium, and we're going to focus again, because that was what Estelle was looking on, mainly on the southern part, the Ardennes at large here. This is one of the more detailed zoom levels, so we're probably overflooding you with a little bit too much information here. But there are basically one unit we will be talking about is this one here, the Stavelot-Venn massif, which is a bit older element inside the geology of Belgium. And we'll also be talking about the carbonate rocks, and they're already visible here, but we will highlight them in one of the next slides. Just to bring you into, to remind you of the map that we are going to try to work to, or that we're going to take elements of and see if we can do something with them. This is one of the maps that Estelle showed you, and it actually gives you the zone of interest that they determined inside their projects at a depth between 3 and 6 kilometers. So we're trying to reach a little bit to the deeper end. One of the first elements, and we're actually going to go to three of them. So these are, we're going to start with indications for fluid flow that we can observe at the surface. And obviously, if you remember from my introduction, fluid flow is really important. It's very nice if you drill a deep rock, which is very hot, but if there is no fluid that you can circulate, you will be forced to, and you can do that to enhance the permeability there, but it's much nicer and much easier to actually drill into something that actually is permeable to start with. So a good way or to finding this kind of anomalies may be to look for areas where there's actually fluids reaching the surface from deep down, because at least that shows that there's a connection between the surface and the deeper part. And you've got here two colors of stars here. The blue ones, which are fluids, cold fluids that reach the surface, but where we have indications that they are at least mixed with fluids that have a deep origin, for example, because they contain CO2 and then often the helium isotopes mixed in them. And the red ones, where we see that actually warmer water is being detected at the surface than we would expect. temperature anomalies. We are trying to collect, well, there is currently no really good overall data sets of this, so we're trying to collect data from different sites. It's a bit of manual labor work. This is done by one of our partners in the project. We added for the Stavelot and the Spa area together with University of Liège some additional part there. And you see that the majority of these fluids are actually quite cold. And we don't have that many indications for, at least in Belgium, for warm fluids reaching the surface. So the most typical cold one is the one around Spa. We have got different of these wells actually reaching the surface. That's why it's highlighted here. Two warmer ones are the ones in the around Chaudfontaine, where you have this, which was already talked about by Estelle. And Estelle, I also think that you mentioned Baudour, where you actually have, well, not at the surface, but at a rather shallow gallery, you have actually indication of a fault that is permeable enough to allow fluids of 50 degrees Celsius to reach that level. Interesting, you would say, I mean, intuitively you would say, yeah, you go for these hot areas and there you start drilling and see if you can reach these deeper areas. And that's one approach, and it's been more or less successful in Mons. Obviously, the real exploration history is a little bit more complex than I'm simplifying it now. But you've got these yellow points, which are actually drillings, not all of them, but several of them, which you find in this area. But in the other on the other side of the country, you have exactly the same rocks which have been drilled, but here you have no surface expression, no geomanifestation of these hot fluids at depth. So there you need to work with geological models and make assumptions on what kind of reservoirs can be down there and if they can be interesting or not. But overall, plotting this kind of information actually does make sense, and you can do some nice things with them. Also, a lot of things that we don't actually understand right now. For example, I said this is a very old structure here, but it's clearly some kind of focal point for getting these kind of sources with mixtures, with elements mixed in from deeper sources to the surface. And they are quite isolated. In the immediate vicinity around that, you do not find similar expressions. And at the moment, we don't exactly understand why this is. We're working on paper, lining out different hypotheses, but this is a story, an element about the geology of Belgium we don't really understand, and which will probably we will probably benefit from if we understand it much better. So it's highlighting some interesting areas and some interesting things to look into. Let's pick a few of the zones, the zones that Estelle picked out, and here you see the blue hatched areas that we've overlain on our map. These are actually the ones that were highlighted in their map as being zones of interest because they contain carbonate rocks at the correct depths. And here we cannot help you with the current state of our structural framework, because we can give you all the carbonate rocks because we did pay attention to these. You've got two shades of blue here, the bright blue and the darker blue, basically being the two, the Carboniferous and the Devonian limestones. But these are currently here only at outcrop level. We will go and include 3D information on those as well, but you actually really need to know where your rocks are at depth to be able to explain these zones that Estelle pointed out so nicely. The reason why we're going through first 2D and then 3D later on is that we actually need to know where the rocks are on surface, not just for geothermal, but certainly also for other applications, and also to be able to have some tie points or tie zones into where we can actually add the 3D model in. And we hope to include the one that is being developed in DG rollout, for example, that will cross different borders, and where this the type localities at the surface will be in Belgium largely. That will, so we're not there yet. I have to disappoint you maybe a little bit on this, but once we are there, we're working also on trying to visualize not just 2D information, but also 3D information into our platform, and actually integrate information work that has been done or is going on right now in other projects. Other zones that Estelle highlighted are the ones where there is hope that these can be naturally fractured. And the reason why we think that is because there are basically seismic activity going on in these areas. That sounds very simple and very easy, because then you would say, okay, if that's true and you look at these zones, let's just plot these data onto these maps and we will see a match. And the reality is a little bit more difficult than that. This is, for example, one attempt to do it, not clearly for the whole of Belgium, but certainly going more or less to this area, here, this top. And these are the seismic data for the last 5 years, and there are already quite a lot of points, but they're actually not nicely lining up with the zones you see here. Maybe it's just because we didn't take enough data. You can do that. And this is from a publication, so the quality is not that good, but you see all of these bubble points showing up here. And there are a lot of points. It's good that the authors actually highlighted that, oh, this is an area of increased activity, and this one is one as well. And these actually do match very nicely with the ones that Estelle pointed out. But it is clear that you cannot just throw raw data on this and then expect an immediate result from that. You need to actually dive into that and do some quiet data, scrutinize the data to actually come up with sensible results here. So this is just to compare that, when I showed you the temperature anomalies, the red and the blue ones, what we did in the project was already data interpretation there as well. We didn't show actual temperatures, it were relative temperature anomalies, where a temperature of water that we found at the surface was relatively warmer than what we would expect at that locality. And yes, you always need to go back, be able to go back to raw data, but it is the actually interpreted data that, in the opinion of myself, and I think of many of us, you need there to find the right balance to present the right level of interpretation when it comes to data. Not in it to hide things, but basically to make it more digestible. And when we talk about that and seismicity, etc., seismicity data is really publicly available. It's quite easy to get it and to download it. There's always a bit of a controversy of how do you link it, how you're going to interpret it, and also it brings you the topic of faults. Because nobody wants to see a fault drawn on a map where his house is or her house is located. These are things that we are aware of in GeoConnect³d, and we have repeated, I mean, it's also part of the whole uncertainty exercise that we do. When we define a fault in our framework, and we're zooming in a little bit because otherwise you wouldn't be able to see it. If you would download this data or look at it in the browser and zoom into it to see exactly where the faults are, you will see that you have the fault, but with an uncertainty margin here of 1 kilometer. And we define that for each fault that we put in our model. And that is actually to represent the actual uncertainty, and we tie it very directly to the data so they cannot be pulled apart. So just a side note on that to show where we are going and what we think is important when we communicate data as well. Okay, in conclusion, so this is a little bit different than the previous presentations. It's mainly taking a topic and seeing how well we are doing right now after 2 years working on this. And I think, especially if you look at the things we did at pan-European level and a little bit more zoomed in, yeah, we can quite easily take results from other studies and one-on-one with well, basically 1 hour of work, put them into our model, tie them together and make sense of them. That seems to work quite well. We also like the fact of basically looking actually at data sets and throwing them in there as well, and see, especially look at atypical areas, a little bit anomalous areas, because quite often there lies interesting questions or interesting answers to be defined that lead to a much deeper understanding. So these things seem to work pretty well, but we certainly, if you talk about the kind of applications we're talking about today, geothermal, which is really something we want to deal with. If we want to go into a real stakeholders discussion, we need this 3D visualization, which is tricky by itself. You need it's a different approach than doing for 2D, and also the models need to be there and need to be ready. And yeah, then I hope with the seismic interpretation, seismic data, I try to highlight a little bit about the difficulty between just trying to go for raw and very honest data and still presenting data that actually makes sense and directly in an intuitive way for the audience. Okay, I thank you. That's my slide, and let's see how Renata is doing, or if André needs to pick in here.
Hi, Chris. I think Renata told in the morning that she has a surprise for me, but I didn't expect to become the host. But I have to have both missions now. So we're jumping to the Q&A session. We're going to have it for 10 minutes, and then we're going to go for the poll, which is actually going to be conducted by Renata, if I'm not mistaken. And then just looking at the questions, they're still coming in. I noticed one, Estelle already started to type some answers directly in the Q&A, but I would like to address the following question. It comes from Serge van Gessel. Besides temperature, fluid and permeability, is there also a need to investigate the local stress situation and faults in relation to seismic hazards? Is this a topic for Wallonia?
Yes, so Chris partly answered to that question in the next presentation, I think. Yes, it was MAPPER in the work in 2011 to address where the seismic event occurs the most in Wallonia, to address this stress situation, but it was not part of a whole work, I would say. So it's something that we should do, yeah, of course.
Yeah. Okay, thank you very much, Estelle. Now Alain Dassarg, he's asking, how do you explain geologically the special case of Chaudefontaine? Do you have not the impression that if we can explain clearly the actual origin of this hotspot, we would be able to understand better many other places in the area of Liège and maybe also in the Ardennes Massif?
Yes, of course. Chaudefontaine is part of was also partly answered by Chris, huh? Yeah, it's a hot anomaly that we should understand better. And I think it was Chris maybe can answer to that because he was working on that area more specifically. I think Chris, you're online.
You're on mute, Chris.
Yes, sorry. Sorry. We're also at the same time trying to move a few presentations from one computer to another. Yes, so I missed part of the discussion. It was about, but it's still the question that Serge?
No, it's the question about the Chaudefontaine. And then Estelle mentioned the fact that you're more familiar with the Chaudefontaine, and maybe you addressed in your presentation.
No, not really. I know it, but not that much in detail. Currently we're working very much on the Spa area. And what was the question exactly?
If we can use the Chaudefontaine as a hotspot, we can use it also in the other areas as an example, and maybe also in the Ardennes Massif. Yeah,
it's a good suggestion, but the issue is, and I don't exactly know that too well for Chaudefontaine, is one of the points with these surface hotspots is that, and that's what Estelle showed as well, they do not point to an anomalous geothermal gradient, but rather to some vertical fluid migration in the top zone. So this means that you get high temperatures at the top, but they stay very stable to a deeper end. So it's not always a good point to actually go for deep drilling and go there, but it does point to good fluid migration. So, and that is probably the more important part there. If actually you can show that this vertical migration does circulate quite a long range, then you are talking, then it's a good indication to have a reservoir with good permeability.
We have also a comment question, which comes from a non-geologist. So, Tine Compernol. He's saying that more of a comment as a non-geologist, as I said, I think it's important that you consider yourself as doctors in a hospital that also have to explain to patients the results of an ultrasound and show where the baby is, or where is the head of the baby, or where is the spine. So I think it's a very nice point of view. So maybe you can elaborate a little bit how we can make our message as a scientist, especially dealing with geothermal, to the larger public. So,
yes, of course.
Yeah,
Yeah,
Estelle,
Chris,
if you want to.
maybe
Yeah.
I think it's exactly the work that GeoConnect3d is doing, and it's what is really interesting to see how to explain and to talk about the underground differently and as with a different level of interpretation of the data and how you can present it to the public and policymakers. Yeah, that's I think maybe Chris is more. Yes, this is really the part of the work in GeoConnect3d, and I really like the way they are presenting everything in that project. Yes.
Yeah, I think it's a very nice analogy, and it's really one of the issues that we are really struggling with. As it would be good to have some opinions also about the audience about that, because it's one of the reoccurring topics of this points of discussion among geologists. That is, what do you actually present? If you ask the Commission, for example, as a general rule, they will tell you, just give us data, we will throw it on a map and everybody will know. And that works pretty well for geographical information, location of shops and location of roads. For geological information, I always had a feeling it works less well. You need to not just give the raw data, you need to give some level of interpreted data, so in order to make sure that it is being understood correctly and then afterwards used correctly. So this is really something yeah, it's never good as only geologists to think about that. We really should think also as a community about how to do that. And we really try to explore that within GeoConnect3d, how to do that, yes. But it's an ongoing exercise.
Okay, thank you, Chris. We have, I think, we can take two more questions. That's one very interesting. It's from Mev Boland. How are you communicating with decision makers about geothermal energy? So I think this applies maybe for Chris, but how do you communicate? Do you communicate with the local or regional stakeholders in Wallonia, Estelle? Do you have open communication, or how does it going?
Wait, was that no? Okay, that was not a question to me, was it? I'm a little bit.
I'm supposed to answer first.
Okay, good. Go.
So how we communicate mainly depends on the level, of course, but yes, we were involved and we are still involved in communication with the Walloon region about how to improve and implement better the deep geothermal energy. So mainly it was more in a traditional way, I would say, and presenting the results of promising area and what is needed to do, what are the next steps. And for policymakers, what was also very important for the implementation of deep geothermal energy, it's about the legal framework and the regulation about deep geothermal energy, because for the moment nothing really exists dedicated for geothermal energy. In the regulation, you can find some different laws that you can apply a geothermal project, but it's one. This is the first point. Without legal regulation, without definition of geothermal energy in Wallonia, it's difficult to attract investors. So it was something that we communicate and we try to discuss also with the Walloon region, and everything is ongoing, and we hope that that will come in next months.
Yeah, and I think also this is an extended discussion about the environmental problems, I guess, because this is the biggest problem when we talk about
the risk and environmental problems. Yeah, exactly.
Yeah.
So we also make the link with other projects, with ASH 2020 project that are dedicated only to that topic. For example, we have the GeoEnvy and GeoRisk project that are especially focused on that topics. And we also try to make the link with the Walloon government with that project, and we have some seminar and different workshop with them to talk about this risk and how to mitigate them and so on. Yeah.
Yeah, so I guess at the general level in Europe, we really need to push for regulation when it comes to geothermal, because it's becoming really a hot topic in the future. I mean, we have the experience with the CCS, which has been really pushed from behind by the regulation, even with the directive. But we see now that the geothermal is taking a lot. So I want to ask, thank you very much, Estelle. I want to ask Chris and Renata, if you can hear me, are you ready to take over for the poll?
I hope you can hear us all right.
Yes, we can hear you.
Okay, so this time it was my turn to have some technical problems. My apologies for that. I'm back. We're just setting up the slides and we'll make a test. How does that go?
Okay, in the meantime, just tell me when you're ready. In the meantime, maybe I can ask maybe one more question. Oh no, we have the poll everywhere already there.
I'll show video as well.
So yes, so we'll give it a go. Thank you very much, Andre, and sorry everyone for these problems. It's not a webinar if there are no problems. So we do a good social distance co-hosting now. And thank you so much, Estelle, for the presentation and for answering the questions. So we'll give it a go if that works. I really hope it does. So we want to hear your thoughts on what you've seen today. So if you haven't done before, you can go to polab.com/videoera900. The link is also in the chat. You register. If you're already registered, you should be ready to go. So I'll try to go ahead and okay, this is not gonna work from this computer. I'm having audio problems. So I will go back to mine and I will share it. And I will pass it over to Andre because I cannot hear anyone back.
Okay.
So I really apologize for that. You know, it happens with these online events. But for now, I will just thank everyone in case I cannot appear again. But okay. Andre, I will share it and give you the control of the activity.
Okay, I'll do my best. In the meantime, asking a question about how do you perceive ourselves the faults, and then Serge asked, does the uncertainty margin also consider the fact that faults are dipping at an angle, or is the uncertainty only considering the uncertainty of the fault at a given depth? Could you hear me, Chris?
Wait, say again, Andre?
So yeah, I was trying to put another question until Renata comes back and give me the poll. So Serge asked about the uncertainty margin display on the screen by you. And then he's suggesting that, or he's asking if you're considering the fact that the faults are dipping at an angle, or is the uncertainty only considering the uncertainty of the fault at a given depth? So it's basically, yeah. I think you already got the question.
Yeah, no, it's a very good question, and indeed something that I didn't show. Depending on which area, we actually have different faults at different levels, fault traces at different levels, and there you can actually see, depending on which one you want to see, you can actually see it, and that gives you also some information about that. The idea is actually in the 3D models to show these lines as well in 3D. But then that means that at certain moments, at larger scales, you're still looking at a 2D view, and then you will look at the Earth as this at the most relevant surface. And but when you want, you can actually look at the faults in full dimensions. I know that Heike is taking a very professional approach to that as well. for us, it's not just the faults, but we have lots of planes which are actually dipping at low angle as well. So it is a very crucial element to consider. And coming from Serge, I know that this is a question we're going to discuss together quite a few times, I think, to come up with the right solution. And right now, I think the outcome of GeoEra will be comparing and convincing in constant communication. But it is an essential topic.
Okay, since I'm not having yet the controls for the poll, maybe we'll actually waive the whole poll. I have another question from Jan Mrlina.
I think it's best to try that. And let's see if the system holds up this time.
Okay.
And yes, we have the control is still here with us, but we're going to try it from the computer we're running on.
Okay.
We don't have at the moment. Renate?
Yes, thank you. Okay, let's try this again. My apologies for this confusing moments. And as for the questions that could not be addressed, we do plan Q&A, continued session afterwards. So you'll be hearing back from us. And sorry to cut this short because we don't want to keep you over the time. So let's try this again. You should be set to go with the poll everywhere. Let's see if that works.
Yeah.
Okay, good. So first question, and going back into Chris's presentation, is the way GeoConnect³ presents geological information is easy to understand. So you can agree to disagree. And we see for now most people agree, which is good. Neither agree nor disagree. And today was a bit of a challenging presentation to do because, as Chris was saying, it's still pretty much ongoing work, especially related to geothermal resource. But it's good to see that no one disagrees. So that's positive for us. Thank you very much for your answers. I'm gonna move to the next one. So the next statement is showing geomanifestations in the structural framework is an intuitive way of indicating geothermal potential. Also going back to what Chris showed in his presentation. So again, you can disagree or agree, and we'll see how that goes. And maybe if I can ask Estelle for a quick comment on that, what did you think of what Chris showed to us today?
Yes, yeah, I'm really in favor of the way you present the data and how it's relevant and more easily to understand. And concerning geomanifestation, that's true. It was a case in Bordeaux, in the Bordeaux gallery. It was clearly certainly linked to the deepest potential. But I would stay a bit more, prudent. How would you say that in English? More careful about that. Certainly for medium enthalpy or low enthalpy could be a good sign. But when we talk about 5 or 6 kilometers of depth, I would not think that a geomanifestation in surface has a link to very deep reservoirs. But I think for all the low enthalpy projects that are going to 300 meters to maybe 2-3 kilometers, yes, I would agree with that for sure.
Nice, thanks. Chris, do you want to add something? No?
No, I think it is indeed a mixed answer. So yes, this is indeed, geomanifestation is not only for a vector to geothermal potential for us. We try to use it here, but it's mainly also a test to how good do we understand the geology. Can we explain all these, for example, fluid-related activities or expressions at the surface? If we can't, and for the moment there are areas in Belgium where we can't, then
we don't really understand what is happening at the level that we can observe best, let alone at the deepest level. So that also, well, basically it's by improving our understanding at the surface, we can also extrapolate better into the subsurface. But say using it as direct indication of geothermal potential, that is maybe a step too far. But it does help to discuss the topic. So in that way, I think it is, I like to have them in there, and they work well to tell stories.
Okay, thank you, Estelle and Chris. So we move forward. The next question, and it's kind of related to the previous one, so you can elaborate more if you want in comments. So what are the pros and cons of the way GeoConnect³ presents geological information? And please indicate if you're talking about a pro or a con. We'll wait until the first answers come in, and you can also upvote the answers that people already gave. So let's see if we have any comments there. But it's, yeah, it's a very valid point that it assumes that people understand maps and 3D models. This is true. It's something that we're trying to improve a bit by defining things, by linking everything into a project vocabulary where you have all of the information that you're presenting defined in words and references. But it is true that some assumption is made there.
Yeah, it's also interesting to see that the in previous sessions as well, it's not only in our sessions, that people say, yeah, do things in 3D. It really looks nice. And projects have done so, and actually you run into a barrier that you've got a very nice 3D model, and yeah, you can just turn it around on your screen, but it doesn't give you the actual information that you need. So it is, I like this comment. It is not obvious to look at a 3D model, understand it, and even geological maps. So we are also trying, and we didn't do it that strong in this presentation, but to work with the zoom levels to make understand just the 2D geological information much more easy to understand.
True. Okay, I see we have some more comments coming up. I find this comment very interesting. Pro fast to integrate results, semicon, maybe an application in the future open for users to contribute and use. That's a very interesting point as well. For sure, the data will be available, but I'm not sure how if it will be possible for in the future people to upload their own data as well in the platform.
There are so many nice options to go for, but yeah, GeoConnect is a much smaller project than we make it appear here. So we need to set our ambition levels a little bit regarding the effort we can put into it. But there will be a lot of suggestions when the project finishes in 1 year. Yes.
Absolutely. So we move on to the next question, and this we would like to hear some ideas from you about what information about geothermal energy needs to be better explained to the public. And again, this one, when we have the first answers coming up, you can upvote them. So maybe Estelle, can you quickly comment on what you think on some ideas that you have of what information needs to be better explained to the public?
Yes, certainly a lot. Of course, as you address first, all the geological and 3D geomodelization are complex to explain to the public, and the geological context and so on. But then we have also the discussion about risk and environmental risk and seismic risk, and we faced it last year also. We had some seismic event related to the Balmat project last year, and of course that that's difficult to explain to the public. So yes, in terms of communication, it's very complicated to explain and to not make the direct link with seismic event and seismic risk with deep geothermal energy. This is something we should address very, very well in the future, because it's a question that come up very, very quickly, usually in discussion about deep geothermal energy. For that, yes, I know that Vito did a lot of communication event and tried to explain a bit more about what happened and so on. So yeah, for me, it was also a point to address if we would like to see some more deep geothermal energy project in the future.
Thank you, Estelle. Yeah, we see some nice ideas there on risk and risk mitigation, how it may affect local population, the risk, but the profit as well for the locals. So that's very nice. Thank you very much for your answers. And we will move forward to the last questions. So this is specifically about this session that suffered with technical problems. Again, my apologies for that. These are very hard to predict, but if you can tell us what are the things that you liked the most about this session. We still have one session coming up, and the Pannonian Basin area will also organize most likely online events like these. So it would be nice for us to know the unpredictable. Yes, it was very unpredictable today. The interactive poll, focus on Belgium, lots of stuff I didn't see before. Okay, that's nice.
Oh,
thank
that's
you.
good to see you.
Yeah, thank you very much for your comments. Presentations were very good. I agree. Interesting review. Okay, thank you very much. So I don't want to keep you much more, so I'll move forward to the last question. And please be kind with us. How would you rate this event? Yeah, I understand the negative results.
It can't be excellent. I mean,
No,
we struggle too much with technical issues.
But luckily, our speakers were fantastic. So this really saved our event. But yeah, most people say it's good, so we're happy about it. I really hope you could see a few new things as someone commented and get some nice perspective on geothermal resource in Belgium. So that's it for today. And just again, a quick note that we're back on Friday, hopefully with no problems. But we're gonna try to link all of these events together in the topic of subsurface management and interactions. So you can still register. I hope to see you there. And if you want to follow us and what we're continue to develop, you can find us all over social media, and we also have a project page with a blog. So the links are all there in the chat for you. And you can also find us in all of these channels. And I thank you very much for joining us and for your patience today. Thanks again to our guest speaker, Estelle, for the great presentation. Thank you, Chris, for representing our project very well. And thank you, Andre, for the moderation. And yeah, please send any comments that you have in our email, geoconnected@geoera.eu. So that's it from us. Thank you very much again, and see you on Friday.
Okay.
Thanks a lot.
Nice day.
Bye.
Bye-bye.
I have to end it.